I am Dr. Vinu. The fundamentals of electrical and electronics engineering. The last topic in the second unit is magnetic circuits. What is magnetic circuit? Magnetic circuit has a closed path through which magnetic flux will flow. The simple magnetic circuit diagram is represented here. Here uh, in the input side, which has the n number of windings, the magnetic flux lines are represented in the dotted line. The mean core length is represented by IC. The cross-sectional area of the core is represented by AC. The magnetic core permeability is represented by means of μ. The definition of magnetic flux. Magnetic lines of force passing through the magnetic circuit is known as magnetic flux. Normally, it is represented by the symbol of phi. The formula for the magnetic flux is phi is equal to B into A, where B is equal to magnetic flux density, A is the area of the cross section, unit is square. The unit of the magnetic flux is Weber. The second definition is magnetomotive force, which is simply represented by MMF, which is producing the magnetic flux. The MMF in the magnetic circuit depends on the number of turns and the amount of current flowing through the circuit. The next definition is magnetic flux density. It is the amount of magnetic flux per unit area at right angles to the flux. The unit of magnetic flux density is Weber per meter square and is denoted by capital B. The formula is given by capital B is equal to pi by A. The definition of magnetic field intensity. Magnetizing force or magnetic field intensity or magnetic field strength is the MMF required to magnetize a unit length of the magnetic flux path. The unit is represented by Henry. It is denoted AT by M. It is denoted by H. The formula is N in the I divided by N. The next definition is reluctance. It is a position that the magnetic circuit offers for a flow of magnetic flux. We can define the reluctance with another definition. It is a ratio of magnetomotive force to the magnetic flux. It is normally denoted by the symbol S. The unit is ampere turns per Weber. The next definition is permeance. Permeance is the reciprocal of reluctance. The ease with which the flux can pass through the material is known as permeance. The unit is Weber per ET. The permeance is equal to 1 divided by reluctance. Self-inductance and mutual inductance. Self-inductance is represented by Henry. It is defined as the flux linkage produces in the coil per unit current in the same coil. It is also defined as the Weber turns produced per unit current in the coil. The unit is Henry. The difference between magnetic circuits as well as electric circuit is represented here. In magnetic circuit, it is a closed path for a magnetic flux forms a magnetic circuit. A closed path for an electric current forms electric current. Magnetic flux does not flow in a magnetic circuit. Electric current always flow in an electric current. MMF is the cause for producing flux. EMF is the cause for producing current. Weber is the unit of flux. Ampere is the unit of current. Flux is equal to MMF by reluctance. Current is equal to EMF by resistance. Reluctance opposes the flow of flux. Resistance opposes the flow of current. Reluctance is equal to 1 divided by mu naught mu r A. Resistance is equal to rho L by A. Permeance is equal to 1 divided by reluctance. Conductance is equal to 1 divided by resistance. Flux density is equal to B is equal to phi by A. Current density J is equal to I by A. Magnetic flux intensity H is equal to N I by L. Electric field intensity E is equal to V by D. Magnetic flux lines flow from north pole to south pole. Electric current flows from positive to negative terminals. The formula for the self-inductance L is equal to capital L into pi by I. Mutual inductance is represented by M. It is defined as the ability of one coil to produce EMF in other coil by induction when the current in first changes. It is also defined as the Weber turns in one coil per ampere current in other coil. It is also measured in Henry. The formula for the mutual inductance M is equal to N2 pi I2 by I1. What is meant by coupling coefficient? It is also known, the coupling coefficient is also known as magnetic coupling coefficient or coefficient of magnetic coupling. It is defined as the fraction of total flux produced by one coil linking the other coil. The maximum mutual inductance occurs when K is equal to 1. M max is equal to square root of L1 into L2. We will see one small problem. Find the maximum value of mutual inductance of two inductively coupled coils with L1 is equal to 100 millihenry and L2 is equal to 20 millihenry. We know the formula mutual inductance is equal to M is equal to K into root of L1 L2. The value of mutual inductance at the maximum is K is equal to 1. So M is equal to square root of L1 into L2, which is nothing but square root of 100 into 10 to the power of minus 3 into 25 into 10 to the power of minus 3, which is nothing but M is equal to